Now let us discuss what are the parts of NC part program. Any NC part program consists of three parts: start program, part program, and end program. So now we discuss how to prepare a part program for the machining operations to be performed. The particulars of the machining operations to be performed is as shown in the workpiece layout given. So now NC part program is to be prepared for performing step turning, drilling and threading operations on 25 mm diameter billet of length 80 mm. So the figure shows the final shape of the workpiece to be obtained after machining. The actual billet dimensions are diameter 25 mm and length 80 mm. A step of 20 mm dia up to 35 mm is to be produced on the billet. Another step of 15 mm dia up to a length of 20 mm is to be produced on the billet. The drilling is to be done on a 15 mm diameter step up to a depth of 5 mm. An external thread is obtained on 15 mm diameter step up to a length of 20 mm. Now let us prepare an NC part program for performing the machining operation shown in the workpiece layout before. As first machining to be performed on the billet is step turning, first part of the NC program should be prepared to perform step turning to produce a step of dia 20 mm up to 35 mm length. Now let us prepare the part program. As it is already discussed, any part program starts with the start program instruction G21 and G98. In this block, G21 instructs the machine that the data is in metric mode, and G98 instructs the machine and tool that dimension coordinate system is absolute coordinate system. G28 U0W0. G28 indicates the tool to go to home position. U0W0 are the machine 0 coordinates. U and W are the reference axes with respect to the machine, which are parallel to X and Z axis respectively. Always, it is mandatory that the tool is to be moved to the home position before starting a new operation, or when it is required to call for a tool change automatically or manually. So before starting the operations of the task, the tool is to be ensured to be in positioned at home position by using this block. M06 T03. In this block, M06 instructs the machine for a tool change, and T03 instructs that the tool number 3 in the turret is to be positioned for the operation. Tool 3 in the tool turret is a turning tool or a left hand tool. The left hand tool is used to process a step cut on the billet. M03 S1500. In this block, M03 instructs the machine to rotate in clockwise direction, and 1500 indicates the spindle speed set for this roughing operation. G00X26Z2 F60. G00 indicates the tool to travel at maximum speed in shortest path. X26 and Z2 indicates the final position of the tool. This code Z00 is used for non-productive tool movements. By using this block, the tool is moved to a point nearer to the workpiece from the home position. Before starting the cutting operation, always the tool is kept at a point nearer to the workpiece, but it should not touch the workpiece. This figure shows the position of the tool with respect to the horizon of the workpiece. Now we prepare a part program to obtain a step of 20 mm diameter on 35 mm length. This figure shows the X and Z directions for the tool movement. The part program to obtain a step of 20 mm diameter on 35 mm length. Z01 X24.5 Z2. In this block, Z01 instructs the machine to move in linear fashion from its existing position to X24.5 and Z2 position. Z01 X24.5 Z-35. This instruction allows the tool to cut the part in linear fashion up to a length of 35 mm. Here the depth of cut given is 0.5 mm. The final position of the tool is X24.5 and Z-35. Z01 X26 Z-35. This block instructs the tool to move to X26 Z-35 position. This makes the tool to go slightly away from the workpiece after completion of the cut in the first pass. Z01 X26 Z2. This instructs the tool to move to X26 Z2 position. This makes the tool ready for the next pass. Z01 X23.5 and Z2. This instructs the tool to go to X23.5 and Z2 position. This prepares the tool for the next pass with 1 mm depth of cut. Z01 X23.5 Z-35. This instruction line makes the tool to cut the material in second pass linearly. Z01 X26 Z-35. Again, Z01 X26 Z-35 moves the tool away from the workpiece after the cutting pass, and Z00 X26 Z2 prepares the tool for the next cutting pass, and Z01 X23 Z2 prepares the tool for the next pass with 0.5 mm depth of cut. Z01 X23 Z-35. Again, this instructs the tool to cut the workpiece linearly to obtain a step of 23 mm diameter for the billet. In the same manner, the next blocks in the part program are prepared to obtain a final step of 20 mm diameter on the billet, with a depth of cut of 1 mm or 0.5 mm for each pass. The number of passes depends upon the final diameter required and depth of cut for each pass. We can notice a new diameter value is given in each block for each pass. So the part program is prepared in the same manner as the first 5 blocks until the tool cuts the material to obtain X20 on jet 35 mm length. So this is the part program prepared to obtain a step of 20 mm diameter on 35 mm length of the billet. The next part of the part program consists of the blocks which instructs the tool to obtain a step of 15 mm diameter on a length of 20 mm. Z01 X19 Z2. Z01 X19 Z2 instructs the tool to move to X19 and Z2 position so that the tool gets ready for the next pass with 1 mm depth of cut. Z01 X19 Z-20 instructs the tool to cut the material linearly to obtain a step of 19 mm dia on the length of 20 mm. Z01 X26 Z-20 instructs the tool to move to X26 and Z-20 position to keep the tool slightly away from the workpiece after cutting pass. Z00 X26 Z2 instructs the tool to move to X26 Z2 position to make the tool get ready for the next cutting pass. Similarly, the next blocks are prepared in the same manner to obtain finally a step of 15 mm diameter on 20 mm length of the billet. So this is the part program prepared to obtain a step of 15 mm diameter on 20 mm length. By this part of the NC program, the instructions to be given to the machine and tool to perform step turning operations on the billet is completed. After completing the step turning operations on the billet, the tool is to be moved to the home position. Z28 U0W0 instructs the tool to move to home position of the machine. M05 instructs the machine to stop the spindle. After completion of each operation, spindle is stopped to avoid any damages to the workpiece and to save power. Now the NC part program is to be prepared to perform drilling operation on the billet, which is shown in the figure before. This is the program to obtain drill up to 5 mm depth on 15 mm diameter step. M06 T02. After ensuring tool is in home position, machine is called for a tool change by using code M06. T02 is the tool to be changed. In tool turret, second tool is the drill bit. M03 S1000. After positioning the required tool, M03 instructs the machine to on the spindle, and S1000 indicates the spindle speed chosen for this operation. Z00 X26 Z2 instructs the tool to travel at traverse to X26 Z2 position. Z01 X0 Z2 instructs the tool to move linearly to X0 Z2 position. This makes the tool to prepare for the cutting pass. Z01 X0 Z-5 instructs the tool to move linearly up to Z-5. This instruction lets the tool to drill the billet. Z01 X0 Z2 and Z00 X26 Z2, these two blocks instructs the tool to move to X0 Z2 first and then to X26 Z2 after completion of the drilling process. G28 U0W0 instructs the tool to move to home position as by now drilling will be accomplished. M05 instructs the machine to stop the spindle. Now an NC part program is to be prepared to perform threading operations on the billet. This program is prepared to obtain thread on 15 mm diameter step. M06 T05. In this block, M06 instructs the machine for a tool change and T05 indicates that the tool to be changed is the fifth tool in the turret. Tool 5 in the turret is a threading tool. M03 X600. In this block, M03 instructs the spindle to on and S600 indicates the spindle speed required to perform the threading operation. Usually, threading operations require low spindle speeds. Z00 X26 Jet2. This instructs the tool to move to X26 Jet2 position from the home position. Z00 X15 Jet2. This block instructs the tool to move to X15 Jet2 position. This position is nearer to the workpiece surface where threading is to be performed. G76 P1000 Q0050 R.05. This Z76 is a threading can cycle and this block is the first part of the G76 can cycle. The parameters P, Q and R in this block are the direct parameters which control thread behavior. Z76 Z-20 X11 Q010 P1532 F2.5. This is the second block of the thread can cycle. These two blocks of the threading can cycle ensures the complete threading operations on the billet. Here, P in the first block of can cycle indicates number of passes, flank angle and thread runout. Q in the first block indicates say depth of normal cut. R in the first block indicates depth of last cut. X in the second block of the can cycle indicates end values in x-axis. Z indicates the end values in the z-axis. P in the second block of the G76 indicates the thread depth. Q in the second block of G76 indicates the depth of first cut. F indicates the thread pitch value and R indicates the thread taper. G28U0W0 instructs the tool to go to home position as by now the threading operation instructions are completed. M05 instructs the machine to stop the spindle and M30 instructs the machine that it is the end of the program as all the required operations are programmed by now. So this is the total part program prepared to perform all the required operations on the billet. Now the part program discussed till now is to be written in a notepad as shown. Save the part program with a suitable file name in any location in the computer. Here the part program is saved with a file name step turning, drilling and threading in a suitable location on the computer. Close the notepad.